Okay, we can simplify algebraic expressions. Firstly, we just need to remember that this sign and this sign are actually now, to make things clearer and cleaner, we're going to take these, and anything that is multiplied is just next to each other, usually in alphabetical order. So negative 7 times x is negative 7x. That can apply there, or it can apply up there, doesn't matter. And then divide by is this line, like a fraction, because divide is a picture of a fraction. So we just do that. See? Okay, so when dividing algebraic expressions, we can cancel the common factors. So in this case, 7, x, just to stay out of it for a minute, 7 and 14 have a common factor of 7, because if I divide 7 by 7, I get 1. If I divide 14 by 7, I get 2. Hence, we have 1x over 2, and of course, you know, we don't need the 1 for there. Now, for this one, we've got 8 squared times b, which is effectively a squared, which is a times b. And if I divide a by a, I get 1. So you're out of the picture, buddy. So we just need a and b. This one is really similar in that we've got 7 divided by 7 is 1. 14 divided by 7 is 2. And now we've got x and y. So we can actually cancel out y over y. Y divided by y equals 1. So that's out of the picture. And then simply get x over 2. Now for this one looks complicated, but it's not. If you stretch it out, you can do 15, common factor of 5, divide by 5, divide 2, or you can actually factorize the thing, and you can see readily there that 10 is 5 times 2, 15 is 5 times 3, cancel out the 5s, and then do the same thing, and stretch out a squared to be the factor a times a, and you've got an a on the bottom as well, so you can kill that bird as well, and then you've got b just on the top. That's how you end up with 3ab over 2. When you're adding and subtracting, you can put like terms together, right? So terms that have the same pronumerals. So it can't be one or the other. You can't combine 3a with 3ab. That's not allowed. But if you got exactly the same, like 5x and 7x, you could add or subtract them because you're saying you have 5x's or 7x's. And in this case, you've got 3 of whatever this creature is here, a squared times b. And in this case, you've got negative 2, but it's the same critter, so you can use your operations to work with them easily. And since a times b is equal to b times a, they're commutative, associative, you can mix them and match them, then these are the same thing. We tend to write them in alphabetical order, it says that here, but sometimes we don't. But the reality is a times b is b times a. So you might look and see if you can change the order around of pronumerals to make you really feel safe about doing that. So like terms can be collected, added and subtracted to form a single term. So in this case, 5 ABs, whatever they are, and 8 ABs can be added to be 13 ABs. I don't need to know what A or B are. I just know that they are going to be multiplied together. I got 5 multiples of that plus 8 multiples of that. So it's going to give me 13. And the one below, I've got a little trickster here. I've got 4x squared y minus 2yx squared. Well, in reality, that is 4 x squared y, we'll keep that order, minus 2, and we know that if we reverse them, y times x squared is the same as x squared times y. That's going to give us our answer. So we're keeping that critter together, and we're just doing the operations with the coefficients. Unlike terms, do not have the same pronumeral factors, so these terms are not alike. So these are all unlike terms. Now let's do some. Simplify 3 times 2b. I like to look at it as 3 times 2 times b. 3 times 2 is 6. 6 times b is 6b. That's all it is. So when we're multiplying, we don't need them to be like terms because we just spread them out and we can see that, I'll show you here as well, that this is the same as saying 6 times a times b. That's how we write it algebraically. And this one is 18 times b. Put it over there just for funsies. So the b's cancel out, bye-bye birdie, and then we find the common factor. Let's see, 6 divided by 6 is 1, 18 divided by 6 is 3, so that's going to give us our answer of 1a, I don't need to write the 1, over, that's it, a over 3. Hashtag winning. So this one's a little trickier, so let's spell it out. We're going to be the same, that above is the same as saying 12 times a, because a squared is a, times b. And divide by, that's the way that we say divide by in maths. 3 times a times b. Did I get it all? I think I did. So a and a cancel out, b and b cancel out, and I want to find a common factor between 12 and 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So that gives me just a plain old 4a, because there's a 1 on the bottom, and I don't need to write that out. Now, simplify by collecting like terms. When you reorder these, remember that that operation, you're going to carry that operation along with you. So you're going to have 3x kind of plus negative 2x plus 4. All I did is reorder the things so I can see in my mind that I'm going to take 2x away from 3x. And once I do that, 3x's minus 2x's give me 1x's plus 4. And I can't do anything more than that because that's as far as I can go with like terms. This one I'm going to do the same kind of thing. Let's see, what do we got? We've got 3x. And I'm going to move the other like term next to it. Plus, they're all pluses. That makes life easier. And so 3x's plus 4x's gives me 7x's. Notice how I'm saying how many x's there are, because we're just adding the puppies together. I've got 7x's to which 2 more are, 7y's rather, to which 2 more are added. That's it. And I can do no more from that, because those are different. They're not like terms, so that is as much as we can simplify. Now, this might look crazy, but let's think of it another way. Let's take 8ab squared. So it's not the same as ab, but this is a like term. And I'm going to take its operator with me because I'm taking away ab squared. And just the same way, I've got minus 9ab, which is a different term, but is alike to this term, plus 3ba. But let's be smart about this. The only reason this works is because really somebody was being a little bit silly and wrote them in the wrong order. It's not necessarily wrong, but conventionally, alphabetical order. If I take 8 ABs, whatever they are, and take away one of those ABs, I'll be left with 7 ABs. Sorry, I should be saying squared. Squared. And if I have 9, you could think of it as negative 9, plus 3, I'm still going to be 6 ABs in the negative. And there she blows.